Now we move from agent architecture to what makes security agents work in practice: trustworthy data, safe tool access, and well-engineered context. These foundations determine whether an agent can act reliably, explain its decisions, and fit into real SOC and response workflows. We've covered agentic security fundamentals, architectures, and coordination patterns. This section shifts to operational readiness: the data, tools, prompts, access controls, and policy context agents need before they can safely support SOC, incident response, and posture workflows. Connecting an AI security agent to enterprise systems is not enough. Before it reasons or acts, the agent needs curated context: reliable data, tool results, policies, environmental state, and case history. If that context is stale, noisy, or incomplete, the agent can miss signals, invent conclusions, or take unsafe actions. Context engineering is the control layer that decides what the agent should know right now. The goal is right context, not maximum context. Useful context comes from several sources. Logs and telemetry show what happened. Alerts and detections indicate what may matter. Network and identity data connect activity to users, devices, and access. Enterprise context explains ownership, criticality, and business impact. Knowledge bases add procedures, threat intelligence, and lessons learned. The goal is not just to collect these sources, but to prepare them so agents can correlate, prioritize, and act safely. Data quality directly affects agent reliability. In real environments, alerts may be duplicated, fields may be missing, timestamps may disagree, and the same host or user may appear under several names. Freshness matters too. A stale asset record can change the right response. Before an agent recommends triage or action, data needs normalization, enrichment, and confidence signals that clearly flag gaps, conflicts, or outdated context. Raw security events rarely arrive ready for autonomous analysis. Parsing and normalization turn inconsistent fields, time, user, IP, process, severity, and category, into a shared schema. Enrichment adds meaning, such as asset criticality, user role, location, vulnerabilities, and threat intelligence. Entity resolution then connects aliases across tools, so a hostname, IP address, device ID, and EDR GUID map to one real asset. That unified context is what makes agent reasoning reliable. When a security agent investigates an alert, event data is only half the story. It also needs the organization's approved knowledge: runbooks, escalation rules, compliance constraints, detection logic, and prior incident notes. Retrieval-augmented context lets the agent pull the most relevant, current, authorized sources before it responds. That keeps recommendations grounded and citable. If the runbook says host isolation requires IR-late approval, the agent should surface that constraint, not improvise. Agents become operationally useful when they can search a SIEM, investigate EDR, query cloud data, update tickets, and manage cases. But every tool is also a potential path for mistakes or abuse. Expose capabilities through narrow, typed interfaces, not broad admin APIs. Separate investigation from response. Require authorization, log every call, and define inputs, outputs, and errors clearly. The goal is enough reach to help, without uncontrolled power. Sensitive actions should never jump directly from agent decision to production change. A tool wrapper turns that moment into a controlled process. First, it checks context: asset criticality, user role, severity, and evidence quality. Then policy constraints apply, such as rate limits, scope limits, allow lists, and rollback readiness. High-impact actions require approval before execution. Finally, every decision is logged with evidence, initiator, and approval status, so teams can audit, monitor, and recover. Permission design is where agent safety becomes concrete. Start by giving agents only the access needed for their task, using role, attribute, and context signals together. Keep investigation rights separate from containment, remediation, and admin actions, because reading evidence is very different from changing systems. Scope each tool by environment, business unit, severity, and incident state. For exceptional actions, use just-in-time elevation, approval, expiration, and logging. Security prompts are operating instructions, not casual questions. Begin by naming the role, because a SOC triage analyst and an incident response assistant should behave differently. Then require evidence-first reasoning. Cite the log, alert, ticket, or source, and state uncertainty clearly. Give the agent a fixed output shape, such as summary, severity, rationale, and next actions. Finally, define boundaries. Which tools it may use, which actions are forbidden, and exactly when it must escalate. Policy has to be more than a sentence in the agent prompt. Instructions tell the agent how to behave, protect sensitive data, escalate when required, and stay within response authority. Runtime controls enforce what the agent can actually do, such as blocking an unauthorized API call. Governance adds audit, review, and compliance evidence. When a request is blocked, the agent should explain the constraint and offer a safe, compliant alternative. Think of an investigation agent as managing a case file, not an endless chat transcript. Raw alerts and tool outputs should be summarized into a current case state, with links back to the original evidence. Short-term task context belongs in the prompt. Durable lessons, patterns, and approved knowledge belong in memory. Most importantly, cases and tenants must stay isolated, so facts from one investigation never leak into another. Before a security agent touches production, evaluate it like a security control, not a demo. Good answers are only one signal. Measure precision, recall, false positives, false negatives, task completion, and time to triage. Then inspect tool use. Did it choose the right API, pass safe parameters, recover from errors, and escalate when uncertain? Reliability comes from realistic incidents, red team tests, regression checks, drift monitoring, and human feedback over time. The core message is simple. Trusted agent action starts with prepared context. Clean, governed data, safe tool access, precise prompts, enforceable policies, and continuous evaluation turn prototypes into operational capability. Next, we'll apply this foundation to SOC and incident response workflows, then extend it into proactive posture management.